Hello, my name is Ana Karen Lozano Ulloa. My ID number is A0-128-5982, and in this video I'm going to explain how I completed the mini challenge 3. Well, the objective of the activity was to create a kinematic simulator using the differential drive module of the DashGo V1 robot. The robot motion is defined by these equations, that is x dot equals v cosine theta, y dot equals v sine theta, and theta dot equals omega, where v is the linear velocity and omega is the angular velocity. Well, the node must receive velocity commands from the command vel topic and then publish the robot odometry in the odom topic. And it must also publish the wheel velocities using WR and WL for the right and left wheel, and also broadcast a transform between the frames odom and baselink. So, well, first I worked inside the ROS workspace Catkin, and I verified that the robot packages were in the source directory. Then we compiled, we sourced it, and then we had to complete this code. The base was given in the GitHub, and I just added a few lines and the code from the while loop. And well, I started completing this code first by defining the robot parameters, such as the wheel radius and the distance between the wheels. Then I created the subscriber and the publisher, the three publishers. I created the subscriber for the command velocity topic using geometry messages with a twist message, and then from this message I extracted the linear velocity and the angular velocity. And then I implemented a kinematic equation of the robot using numerical integration method, well, more specifically using the Euler method to update the robot position and orientation over time in our simulation. And well, then after computing the robot state, I created the publishers, these publishers, using nav messages odometry, and these were published to the odom topic. And well, I also computed the left and right wheel velocities, and that are published in the topics WR and WL using flow32 message type. And well, finally I updated the transform between the frames odom and baselink using quaternions in here. And yeah, this is basically so the movement of the robot can be visualized in the RVs. So now to run our simulation, in here we already have ROS core running. Then in a different terminal, we use the ROS launch -go v1 robot.launch. This is to run the RVs. So now the RVs is running. I'm gonna put this here in a side, just so we can finish the rest of the terminals. And then in here, I'm gonna kill it so we can run the code again. But in here we use ROS run to the teleop twist keyboard. This is so we can control the robot with the keyboard. And well, now here in RVs we have to change the fixed frame to odom. And well, now in here we can see visualize different commands. But for example, I'm gonna start using the ROS topic command velocity. And well, if we move our robot to the front, as we can see, we have our linear motion in the x axis. Actually, I'm not sure about this, but I think the positive axis should be following the red line. But this is actually happening because I decided to change this part of the robot kinematics, because when I clicked I, it went backwards, and when I clicked comma, it went frontward. So I decided just to flip these these equations using minus sign in here. So that's why it might be going to the position, to the inverse position. But yeah, well, we can see, for example, in here the rotation, then the rotation to the other side, and we can see it in here. We can also use a different topic. For example, we can use the wheels or the odom, and it would happen the same thing. As we can see, they're changing. This is changing constantly. The rest of the of the publishers publish in every movement, as we saw in the command velocity. Now I'm gonna kill it. As I said, we can also use, for example, ecotopic, topic echo WL for the rotation in the left wheel, for example. We can also use WR. And we're getting the data. And yeah, this is basically it. Thank you for watching.